Right, so in this question, it says the stone is thrown vertically upwards at a speed of 14.7 meters per second, as I've got there. Okay, so we take upwards as positive, right? And of course then gravity is working opposed to that, working downwards. From point A, which is 49 meters above the ground, okay? So there's my distance there above the ground. So it says, and find the time taken for the stone to reach the ground. Okay, so part A then, we know U is 14.7, so let's get this into place here. So we want the time, don't we? It takes to reach the ground. Now, we don't know the final velocity when it hits the ground, because when it hits the ground, it's still traveling, okay? A common misconception is people think that when it hits the ground, its velocity then is 0. And that's not the case, because you know, it would have a really soft, gentle landing then, wouldn't it, if that was the case? But that's not usually what happens. It'll hit the ground at speed. Sometimes it will sort of indent the ground. It'll go into the ground, okay, because it's hitting it at speed. So the final velocity isn't going to be 0. Acceleration is, it goes minus 9.8, because we're taking upwards as positive, remember, because it was thrown upwards to start with. So if we take upwards as positive, A then is going to be minus 9.8. Okay, and the other thing then we're looking for is S. We actually know what S is, and in this case, S is going to be minus 49. Okay, and that's what it is, because S, remember, is displacement, and it's going upwards to start with, so upwards is positive, but then we're interested in when it actually goes down here then. So displacement is 0 here, so when it goes down here, it'll be negative 49. Okay, so that's what we need to put in here. So then, knowing U, A, and S, and I want T, so what I need to do is then I need to use S equals UT plus half AT squared. Okay, so put minus 49 in there for S. U then is 14.7. Okay, T. Then we've got plus half. We've got A is minus 9.8. Okay, T squared. Right, so we've got that there. Now perhaps to simplify a little bit here, I will do 14.7 t, that will be minus 4.9 t squared. Okay, and it's kind of looking like a quadratic now, isn't it? So you've got a t squared t, a number. Let's get everything onto one side. 4.9 t squared. So take that over, and then become minus then 14.7 t minus 49 equals 0. Now I can't solve this, can't put it into brackets as it is, right? Because it's going to be too challenging for me. We've got decimals here. We could use the formula, but often with these questions, right, they can factorize without using the formula. So we can just play around with these numbers here. Now when I've got decimals, the thing I'm tempted to do is by timesing through by 10, okay? Because if you times through by 10, you then get 49 there. You then get 147 here, or minus 147t, and of course that would be 490, okay? And then, right, we can do more. We don't have to leave it like that and factorize now. We could see, are there any common factors here? And if you notice, 49 there, 490, so 49 divides, and actually 49 divides into that as well, okay? So we could now divide by 49. So we divide that by 49, you get 1, so that'll be t squared. You divide that by 49, you get 3, exactly. You divide that by 49, you get 10, okay? Equals 0. So then it's much simpler. 2 brackets, 2 numbers that multiply to give minus 10, add up to give minus 3. So 5 and 2. Of course, I think that's going to be a minus, and that's going to be a plus. Okay, that would work out for me then. And then you'd say, well, okay, t plus 2 equals 0, or t minus 5 equals 0. So t equals minus 2. Now that's sort of impossible, isn't it? Okay. For time, that's an impossible situation. So that means then t would equal 5, which is our correct answer. Okay.